Right, so today we're going to learn about long division, a quick revision on what we've already done. So I've given you an activity to complete for division, which is in your textbooks from page 88. So I'm just going to do a quick revision with you, a reminder on the steps that you have to follow when you do your long division. First step is to divide. The second step, you have to multiply. The third step is subtract. And the last step, you bring down. Okay, so what I'm going to do now is to do one example that involves a division, long division. So here we have 240 divided by 60 divided by 36. All right, so if we divide it by 36, we need an answer. We're going to use long division. This is our long division sign. We put 240 below. If we ask ourselves, how many times does, excuse me, it's 8,643. It's from your textbooks, page 91. So that's 8,643 divided by 36. So we ask ourselves, can 36 go into 8? No. Can 36 go into 86? Yes. How many times does it go into 86? It goes twice. So 2. 2 times 36, we now multiply. Step number 2. Done step number 1, which is divide. 2 multiplied by 36 will give you 72. We now subtract. 6 minus 2 is 4. 8 minus 7 is 1. We then bring down the 4. Okay, as we bring down the 4 and the 3, we ask ourselves, how many times does 36 go into 1,443? That will be 40 times. So we have our 40 there. 40 times 36 gives you 1,440. So we have divided, we have multiplied, we now subtract. 3 minus 0 is 3, 4 minus 4 is 0, 4 minus 4 is 0, 1 minus 1 is 0. So our answer to 8,643 divided by 36 is equal to 240 remainder 3. All right. I am going to do a word problem solving example, taking the question in your textbook on page 92, exercise 14.5. Okay, so the question reads, Mr. Henrik has 630 eggs. He packs the eggs in trays. Each tray can hold 48 eggs. Question 1. How many complete trays can he fill? Okay, so we know that we have 630 eggs that have to fit in packs of 48. So that will be 630 divided by 48. Again, we're going to follow our long division procedure. So we write that using our long division symbol. First step is to divide. 48 goes how many times into 63? It goes 1. 1 times 48 becomes 48. We then subtract 3 minus 8. It's not possible. So we're going to take the 1 from the 6 and we'll be left with 5. Then the 3 becomes a 13 as we move the 10 to the other side. 13 minus 8 becomes 5. 5 minus 4 is 1. When we bring down the 0, how many times does 48 go into 150? It goes 3 times. 3 times 48 is equal to 144. We now subtract. 0 minus 4 is not possible. So we're going to take the 1 from the 5th. And that becomes 10. 10 minus 4 is 6. 4 minus 4 becomes 0. 1 minus 1 becomes 0. So our answer is 13. He can be able to complete 13 trays. Okay. The second question asks us, how many eggs will be left over? We know that we have a remainder of 6 there. So 6 eggs will be left over. How many groups of 630 does he need so that the trays are full with no remainder? Now, this is where you have to apply some of your basic mathematics skills. Now here, you know that for each and every 630 eggs, in trays of 48, there is 6 that remains. So, how many 6 eggs do we need to make up 48? We need 8 eggs. So we know that 6 times, we need 6 eggs of 8. So 6 times 8 will give us 48. So we know that we need 8 groups of 6 eggs in order to have a tray of 48. We'll then now know that, okay, we need how many groups of 630 eggs? We need 8 groups. So we need 8 groups of 630 eggs so that Mr. Hendrik can have a full tray of 48 eggs with no remainder. Okay. I'm going to move on now to decimals, which is the most recent work that I've sent to you via the school's email, and I hope you've all received. This topic is found in page 96 of your textbooks. All right, decimals. Now, there is a way in which we can represent right decimals and also pronounce them. Okay, so we have an example of a decimal number, 892,73. Now you know your number chat that we have your place value chat. You'll have your hundreds. You'll have your tens, and we have our ones. Now going beyond further after the ones, then we'll have the comma. So the comma will be there, and we now have tens, and we also have hundreds. That is after the comma. Okay. So for here we have 800, 9 tens, 2 ones, comma, that is the decimal. So we have 7, that will be over 10. As we move to the right after the comma, we are dividing by 10. So we're moving again to the hundreds, we are dividing by 10. So this will be 3 over 100. So this is what it means for this number. So we will see how we can break it up. So we can expand this number according to its place value. So this will be 800 plus 90 plus 2 plus 7 over 10 becomes 0.7 plus 3 over 100 becomes 0.03. Okay, so now we know that after the decimal, we can say for one decimal place. So after the comma, for one decimal place, it will be a 10. And for the second decimal places, it will be 100. So it will be that number over 100. So we'll also look at a few examples here. I'm going to do one example on page 96 of your textbook, exercise 15.1. It says write the following as decimals. So I'm going to write that on the board. So they give the numbers, the decimals in words. 31, 12. So this will be 31,12. So we know that we have 3 tens, we have 1 ones, and then after the comma, we have 1 10, and we have 2 hundreds. Okay. Now another example. So this will be A, and I can say C. 43,45. 43, comma, 45. Okay, and you also realize that the numbers that come after the comma, we don't actually pronounce them as ones like we do before the comma. So here it's 31, 12, not 31, 12. So we say 31, 12, 43, 45, not 45. And how we write this would be 43, 45. Okay, so let's do one where we can expand the decimals. So we have to expand the following decimals. I can actually expand the ones that we've already done as examples. So if I would write this in expanded form, it will be 30 plus 1 plus 0, 1 plus 0, 0.02. This one in expanded form will be 40 plus 3 plus 0.4 plus 0.05. Right. The 1 is in the first decimal place, the 2 is in the second decimal place. The 4 is in the first decimal place, and the 5 is in the second decimal place. Okay, and we'll do exercise 15.2 now. Just two examples as well there, which is on page 97 of your textbooks. So we have to continue the given sequences in decimals. So the first sequence goes like this: 0, 1, 0, 2, 0, 3. So if we were to continue with this pattern, it will be 0, 5, 0, 4, 0, 5, 0, 6. The second number decimal sequence that we are given is 1.7, 1,7, 1,6, 1,5. You can see that this is now descending. The next one will be 1,4, 1,3, 1,2, 1,1. Okay. You can also use a number line to help you not to make to avoid making mistakes. So you know that if you drew your number line like this and you have your 0, 1 there, know that that will be 0, 2, 0, 3, 0, 4. So if they can say, they give you a question to say 0, 1 plus 0, 5. You know that you'll be moving to your right 5 times, starting here at 0, 1, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So you know that that will be 0, 6. Now if you were to subtract, you will be moving to your left. So if we have 0, 5 minus 0, 2, you can say, okay, there's 0, 5, I'm going backwards twice, 0, 1, 0, 2, so that's minus 1, minus 0, 1, minus 0, 1. So your answer therefore will be 0, 3. Okay. Oh, actually, you're missing that. Sorry about that. Okay. So 0, 0.4 minus 0, 2 will give us 0, 3. Okay, we can convert common fractions to decimals. Okay, but by doing that, we must make sure that our fractions are always having a denominator of 10, 100, 1,000, and so forth. So for instance, if you have the common fraction 1/2, you know that this is 0, 5. But the way we know this is converting the denominator into a 10. So how can I do that? How many 2's do I need to make a 10? I need 5 2's. So I multiply that by 5, I multiply that by 5, it will give me 5/10. Then you know that this is 0, 5. Okay? 1/4. So this is one of the common fractions. How many 4's do I need to make 100? Okay? I need 25 fours. So if I multiply 25, I have to multiply the numerator by 25 as well. Right, bigger so you can see. So common fraction is 1 over 4. I multiply this by 25 because I need 25 fours to make 100. So that will change my fraction to 25 over 100. And this will be 0.25. Okay. Last example for you. If I have 2 over 5, how many 5s do I need? I can convert the denominator to 10 by multiplying 5 with 2. So that will be times 2 times 2. So this is equal to 4 over 10, which is equal to 0.4. All right. This is where I'll end my lesson, guys. It was nice to be with you, and I hope you enjoyed the lesson. Please stay home, stay safe, respect social distancing if you're gonna go out, and hope to see you soon. Goodbye.